Hi, this is December 2025 for Part A questions 16 to 20 in this video. After this, at 10 p.m., I'll be going live discussing grid methods, which are basically two circle when questions. So that'll be around from 10 o'clock to 10:30. Beginning with question 16, two paired dice are thrown at random independently. What is the probability that the average of the values on their upper faces is 4? So these are the options you get for a sum of 4. And there are 36 outcomes in total. That is from 1, 1 to 6, 6. Yeah. Yeah, like that. So these are 36 outcomes. Out of them, the ones that give you 4, a sum of 4, is 2, 2, 1, 3, 3, 1. And that's it. I don't think so. There are any other. So 3 out of 36. 1, 1, 1, 3. Sum of 4. Maybe 1, 2, 3. No, I'm missing out. No. Yeah. So 3 out of 36. It's 1 by 2, 1 by 12. Not there. Where am I going wrong? Two fair dice are thrown at random independently. What's probability that the average of the average? Oh my god. Okay. Gotta read your questions carefully. I thought it was sum, but it's average. So average is 8. So the sum should be 8, not 4. So the sum being 8 will be 5, 3, 3, 5, 4, 4, 2, 6, 6, 2, and yeah, 5. 5 out of 36. So my answer is 5 out of 36. A. So why the sum? Sum is 8. So 8 divided by 2 will give me 4. So I should be looking at a sum of 8. Moving on to question number 17. Okay. Now, this question 17 is asking an experiment has collected data in some units which is presented in the below XY graph. What would be the best function to fit the data? So we know that K is a positive constant, okay? Yeah. So suppose if I take K is equal to 1, then I got this as cos X, and cos X graph looks something like this. At 0, it is 1. So it would go like this. Yeah, this is my 2 pi period till here. And this is my negative 1. So I know that it will the amplitude will remain constant out here. Yeah. So the amplitude is changing from 1 to, and it's decreasing, decreasing, and decreasing. So this is out. And now, if K is 1, I've got sine X square. Okay. Sine X square. So sine X square, again, out here, the amplitude part we can calculate. Now tan will go out because tan, we all know that it has an infinite case. Okay. So your K being 1 and X cube being whatever, it's gonna have some infinite case to it. Yeah. And this is not showing an infinite amplitude. So this is out. So you have a choice between 2 and 4. So now which one would you go for? So what I'm going to do is I'm going to use the value of K and solve for the fourth option because I feel that fourth is most probably the right answer compared to the second one. So suppose if I take K as 1, then I got e raised to minus X cos X. Yeah. Okay, and these are my x values out here as been shown out here. So if I take x as 1, which is this is in radian angle. So if I take cos as 1, so in case of radian angles, let me see. If I take 3.142, let me take this as 3.142, which is equal to pi. Yeah. So this is my pi value. Okay, which is 3.142. So if I take cos of pi, then meaning x as pi, then I got e raised to minus 3.142. Yeah. I've got cos as pi in a way, in radian form. Then in that case, the value of pi would be negative. 0 cos of 0 is 1, but cos of pi will be negative 1. So I've got a negative value out here. And this one, e raised to something negative, you can find out using the calculator on screen. So if I use an on-screen calculator, I'm using my phone. I'm putting in a negative value. So negative 3.142. And I'm getting a positive outcome out here. So there's some positive outcome. So to be precise, it is 0.043. Yeah. So 0.043 into negative 1 is negative 0.043. And out here, it seems to be the case. Sort of. Yeah. Now suppose you want to take, let's say, cos of pi by 2, which is 3.142 divided by 2. So maybe the first value was the coincidence, so I'll take another value. So I'm taking x as pi by 2, okay? And when I take x as pi by 2, I'm getting a 0. So pi by 2 would be 3.142 divided by 2, meaning pi by 2, 3.142 divided by 2. So I'm getting 1.57. So somewhere here I'm getting. So it gives me a 0 outcome, because anything into 0, this into 0, when I take x as pi by 2, I'll get a 0. Yeah, and which is correct. So therefore, I'm not gonna waste time checking the second one. I'll just go with the fourth one. It's a bad explanation, but that's what I've got. You can comment all those things that you'd like to comment in this video. 18. The square of the geometric mean. Now pay attention to the words out here. They're asking not the geometric mean, but the square of the geometric of two positive numbers. So let the numbers or integers be a and b. Yeah. So the square root of ab is, and square of that is 30. So first of all, remember geometric mean is, suppose there are three numbers a, b, c, and you have to find the geometric mean of this. Then you multiply a, b, c and take the cube root of it, not square root, cube root, which is basically a, b, c raised to 1/3. So when there are two numbers AB. So you take the multiplication of AB and you raise it to power half, meaning you're taking the square root of AB. That gives you the geometric mean. So out here they're saying that two positive numbers, square of the geometric mean of the two positive numbers. So first of all, what is the geometric mean? It is square root of AB. And then you're squaring it. So you're left with AB in a way. Understood? So that is AB raised to half, and then you're squaring it. So that is AB. So AB is 30, they're saying. So that means I'll take 6 into 5. I'll take 5 into no, I'm sorry, 3 into 10. Yeah, I've got this answer. I've got this answer. Yeah, but the question is the smallest possible sum of the two integers. So the sum is, see, I'm getting a sum of 13, 3 into 10, 6 into 5. I've got 1 and 30. So 31. 31 option is not there. And then what two numbers when multiplied as integers gives me 30? So 6 into 5, 3 into 10, 1 into 30. What else? Can you think of any? None. So that's it. You got your answer as 11. Okay. Yeah. So I honestly did not know geometric mean, in the sense that I'd forgotten. There are several things in math that you forget. So all you have to do is look it up, and it's just a 5-minute revision and you're done. 19. A block of marbles 4 meter. Hang on a minute. Hang on a minute. I think I missed out a question. 16 done. 17 done. 18 done. 19. Okay, that was fast. Okay. 19. A block of marbles 4 meter, 3 meter, 2 meter in size is cut into square tiles of 1 meter side. Square tiles of 1 meter side having thickness of 10 centimeters. Assuming there's no wastage in cutting, how many tiles will be made? So imagine it's like a box, okay? So you've got a box like that, okay? And it's not a cardboard box, but it's a solid marble block, okay? Which is 4, and I would say this is 3 and this is 2, okay? And the tile thickness is 10 centimeters. The square tile thickness is 10 centimeters, but it's a 1 meter square side. So I'm going to use this as 0.1 meter, 10 centimeters, 0.1 meter. Yeah, 10 by 100. So how many tiles can be made? So first of all, if my length is 3, yeah, then I have 3 divided by 0.1, which is 30 by 1. Okay, so I've got 30 such layers. You can say 30 layers. Now, in one layer of thickness 10 centimeter or 0.1 meter, how many 1 meter square tiles can I get? So 4 into 2 is the area, 8 meter square, divided by 1 meter square. So I'm getting 8 tiles on one layer. So 30 into 8, 30 into 8, see what I'm writing, 3. So yeah, be careful. During the test also, silly errors you could make. Fortunately, 30 into 3, 90 option was not there. So 30 into 8, 240. That's your answer. Last question. An OTP is made up of 6 digits, 0 to 9. If 3 digits are and their positions are known, 3 digits and their positions are known, what is the probability in percentage of discovering the full pin within 100 trials? Now, first you check in the question, are they saying the OTP, all the digits are different? No. Okay, so assuming that the first 3 digits, meaning the first 3 positions are known, yeah, it's a 6 digit, right? So there are 6 blocks, and then digits can be repeated because they've not said digits once used cannot be repeated. So I can say I've got 10 options, 10 options, and 10 options. So I've got 1000 as my total outcome. Like in 1000 trials, I'll definitely get my OTP. One of them will be my OTP. So the question is that what is the probability of discovering the full pin within 100 trials? Now, you should leave such questions, yeah, because you would probably say, okay, out of 1000, I've got 100 trials. So 100 trials, so it is equal to 1 by 10, and they want the percentage, so your answer is 10%. But the clarity out here is required because what is the probability in percentage of discovering the full pin within 100 trials? So you try 100 times, yeah, and there are 1000 possible outcomes, yeah. So in 100 trials, if you get it, then there's a 10% chance that you get it, but there's a 90% chance you don't get it, right? So that's how you need to think in such questions. So I'm sure that permutations probability would be an issue if they give such questions, and normally they would probably just ask you that, okay, they would probably ask you that how many combinations would be there if the probability is not there, and they're asking a permutation question. then they'll probably ask you in how many combinations or what is the percentage of getting the OTP correct, leaving the 100 trials out. So the percentage for you to get your OTP right, trying out only once, is 1 by 1,000. But trying it out 100 times is 100 by 1,000. So this is the level of thinking that you require to explain yourself that you're getting the right answer, which is 10%. So this is how you need to talk to yourself when you're solving the question that, okay, if I were to rephrase the question and ask myself that I'm getting only one shot, one trial to get that OTP right, then out of 1,000, I should have only one possible way to get it right. So 1 by 1,000. So that's one trial. Within one trial, I need to get it right. So if there are 100 trials, so 100 by 1,000. So 100 by 1,000, which is 1/10 chance I've got of getting it right, which is 10%. So yes, a good question out. And with that, I'm done with the part A December 2024 paper. In these videos in my channel, as of now, I'm only discussing part A. Yeah, I'm not sure whether part A logic is applicable to chemistry as well and life sciences as well. So if it is, then you're welcome to watch these videos, see if you get to learn anything. Tonight, I am planning to do the grid methods, which is two circle when questions, a brief video of 20 minutes. Yeah, I'm going to go live. And obviously, going live doesn't mean that I'm going to FaceTime. It's just going to be the way I've uploaded these videos. So that's about it. Thank you.